So for our next problem, we are actually finding the missing coordinate. So we are finding that missing value. Notice here again they've given us a point, and in this case they've only given us the x point, or the x value, and we don't know what our y value is. That's our question. So kind of similar to what we did on the previous example, we're going to plug in what we know and we're going to find what we don't. So in this particular instance, we are going to substitute 4 in for x and solve for y. Okay, so we're going to do 6 times 4 plus 2y equals 5. And then we're just going to go through the process of solving this just like we did in chapter 8. We're going to multiply 6 times 4. That's going to give us 24 plus 2y equals 5. We want to get our 24 out of there, so we're going to subtract 24 from both sides. So 2y equals a negative 19. We're going to divide both sides by 2. And y equals a negative 19 over 2. And this is the answer that we're looking for. So we would put negative 19 over 2 in our answer box. So again, just like the previous question had 2 steps, this one also has 2 steps. I'm still using my 6x plus 2y equals 5, but this time it's giving me the point something and 1/2. So this time it's telling me that y is equal to 1/2. So I'm going to plug that in for my y value and solve for my x. So just making sure that I know exactly what value it's giving me and what place in the point it is. And remember, my point is always x comma y. So we're going to have 6x plus 2 times 1/2 equals 5. Now remember, when you're multiplying fractions, it is always top times top, bottom times bottom, and if you have a whole number, you can place him over 1 so that he is a fraction just like the other one. So this is going to be 6x plus 2 over 2 equals 5. And we can definitely reduce 2 over 2, and we always want to make sure we have our fractions in their most reduced format before we decide what else we want to do with the problem. So this is actually going to be 6x plus 1 equals 5. So now we're going to solve for x. We're going to subtract 1 from both sides. I'm kind of running out of room here, but we have 6x equals 4. I'm going to bring this up over here so we can continue. 6x equals 4. Now we want to divide both sides by 6. That's going to get my x by itself. But notice that this 4 over 6 can be reduced. And we always want to reduce our fractions to as low as they can go. So we're going to divide out of 2. And x equals 2 over 3. So this is my value here in that parentheses. Now I've given you these examples and they did come out as fractional answers. You will have some in your homework that will come out to whole numbers. I just wanted to kind of give you the more challenging ones as a video to look at, but know that you will have some in your homework that do come out to whole numbers. So for our last example for this section, or for this video, we are looking at a very similar problem to what we just did. It's just presented to us in a different format. So here, instead of presenting it to us as 2 steps, they actually presented it to us as a chart. So notice that they've labeled the first column as x and the second column as y. So for this first point, that is a point, -3, comma, something we don't know yet, we're going to plug in -3 for x and solve for y. And we are using this equation up here at the very top of our problem, y equals -2x plus 2. So we're going to say y equals -2 times -3 plus 2. Let's do our multiplication. So -2 times -3 is a positive 6 plus 2. So y is equal to 8. So there's our first point. When x is -3, y is 8. we're going to do something very similar here, but notice that my 2 is in the y column this time, and I have a box here for my x. So this time we're going to plug in 2 for the y, since he's in my y column, and we're going to solve for x. It's really important that you understand what we're doing here, because this is kind of the backbone to graphing lines, is to be able to plug in a number for an equation and find its corresponding value. So here we've got 2 equals negative 2x plus 2, and we're going to solve for x, so we're going to subtract 2 from both sides, and we get 0 equals negative 2x. Remember, 0 is a perfectly fine number. There's nothing wrong with that. So we're going to divide everybody by negative 2, and we're going to find out that 0 equals x. So when x is 0, y is 2. Now for our second half of this problem, what we're going to do is take these two values we just found. So again, thinking about it, we just found negative 3, 8 and 0, 2, and we're going to graph these 2 points on the number line, or on the graph that we've got here. So negative 3, 8 would be to the left 3 and up 8, so 1, 2, 3, 8. So this would be our point. I don't need to label these because I am just drawing 2 points on a line so that I could connect them if I wanted to. So you don't need to label A and B like we did on that very first example. So then the second point is 0, 2. So since my x is 0, that means I'm not going to go left or right. So I'm going to stay right here at the origin, and then because my y is 2, I'm going to go up 2. So I'm going to get at that point right there. Now, if I were to connect these 2 points, I would have drawn the line that represents y equals negative 2x plus 2.